Okay. Um, um,
Hey, good morning, Babak.
Good afternoon.
How are you doing? How was the trip?
It was good. It was good. I just it was back to back because I came from Singapore
Uh-huh.
and then I had to go teach and then I flew to Dublin. But it went well. I spent the whole day there. It was nice. It's small. The
Uh,
the
right.
the event is fairly small.
Yeah, I think also the number of people traveling kind of reduced this year, probably.
Ah,
Uh,
yeah.
right,
Okay.
right. But
Okay.
thank you for covering, and it's really
Oh, you're
wonderful.
welcome. No, I had a good time. So,
Good, good.
run into the usual suspects. I don't. Yeah.
Good, good, good. Maybe we'll give a few more minutes. The others will join.
I had a question for you, Sammy.
Yeah.
You, I, I think our co-lead hasn't been attending these meetings.
Nisie actually attended last week,
Okay,
and
okay.
no, last week or the week before that
I see.
thing, right?
Because I
Uh,
presented her, but I didn't know, and then I realized I actually haven't met her.
Yeah, I think hopefully you'll join today. Let's see.
I'm not attending all the meetings either, but
Right, 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 right. I think that meeting, Sadas was not there. I think he was also had a conflict, and you were not there. And uh, ended up myself and somebody else attended first time.
sounds good. And you're not, are you gonna make it to Singapore or what is, these guys were, I can't make it because I'm traveling at that time. There was a proposal to go to Singapore.
Oh, is that another
There's Tutti.
APEC?
Yeah.
Okay, okay. No, I am not aware of it. At
Oh,
least
you
not.
didn't get the email?
I didn't probably process it, even if I got the email.
Oh, I see. Okay.
Yeah, right. So when is that going to happen?
It was July 12th, I think it's, yeah.
Oh, okay.
Yeah.
Yeah, I see announcement. Next Gen AI clusters.
Yes. I just came from Singapore. I would have,
Oh, right, 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 right.
a nice place to go, but yeah. It's also a difficult time of the year because it's super hot there at that time.
And I'm thinking of making a trip to India. So probably Singapore is not too far for me, but
Oh, okay, yeah,
let's see.
sounds good.
But it's again depending on what the theme and what they're trying to cover, right? I know like there is a um, China, they are planning to host one, and Taiwan, they were planning to host one. There's a
Oh,
few different APAC they were planning on it, I believe.
oh, okay, and is there any time frame for those?
One I heard May 22nd. I believe it's also in this announcement, I believe.
Okay,
So next year is going to be Spain, looks like. Okay.
okay, well, that's close to me.
Yeah, give a couple of more minutes and then
Okay.
even if not there, I believe it gets recorded so we can talk on that. I think it's 5 after. Probably let's probably talk through how it went and a little more detail on what type of feedback, how big attendance, what is the interest there, right? Uh, Probably you want to uh, give a kind of how big audience was there in the.
Yeah, yeah, we had probably around 30 people in the room in the
Oh, that's good.
sustainability track. Yeah.
Right, right.
It was roughly the same number
Okay.
as the previous event.
Right.
But the previous event had 7,000 people, and I think this was smaller. This was, I don't know. I don't know how many people were there. Maybe 1,000 people, maybe less.
Okay. Okay.
But
But at
the
least good interest then. 30 people in that uh, it's really good. Yeah.
yeah, but I think that partially also because uh, Alex has a full program for the whole
Right.
day, and the presenters are there. So
Right. Right.
the
Right.
presenters already account for at least a third of the audience.
Okay. 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 It's
Yeah.
going serious and the people are attending. Yeah. Okay.
Yeah.
And are you able to cover did you have enough time or is it a lot more materials than in the allocated time or?
No, I practiced it.
Okay.
I didn't realize that they wanted me to present from my laptop. So when I was sitting there, I just made a bunch of formatting changes. So
Okay.
some of the fonts appear more properly. There was a couple of typos. I fixed the typos, but they yeah, I practiced it, right?
Okay.
And so I think it went well. I made sure it fits.
That's good. And you had enough time to Q&A.
Yeah, we had a little bit of time for Q&A, and we had that question about adiabatic, I think, but it wasn't. We didn't get a question about the things that we really wanted to sort of work on. I did advertise that we're really looking for people who want to give us data.
Okay.
Yeah, and I also said that, we have, I was talking to, I don't know who I was talking to actually with somebody from a startup who connected with me. It's a startup that uses AI to monitor the IT stack and make it more efficient. So they could actually work with us on the metrics. But
Okay.
he said that Green Grid
Yeah, green grid.
had data many years ago. I don't know if they were made in public, but they had actually collected a lot of data and said that maybe we can contact them to see if, that there's any way to use this data. Is Green Grid a member of OCP? I don't know if are they?
They were not really, at least a couple of years back, we were trying to do something with OCP and Green Grid. I think they were a kind of parallel organization. People from here, they were attending Green Grid also.
Yeah.
But I believe the OCP staff was trying to close the bridge. I'm not sure where we are right now, but I know a few people from OCP really attending Green Grid also.
Okay, good. Yeah. So that's one possibility. I think that getting data from the national labs is okay, but I think that the academic sites and the supercomputers will fundamentally have workloads that are a little bit different in characteristics than what people do in the cloud.
Okay. It's good to have some real world data that people can look at it and play with it, right? Yeah.
Exactly.
Hi, James Frey.
Hi, James.
Hello.
Thank you
Nice
for
to,
joining.
yeah, nice to have some new friends to meet here. Thank you for making it so easy to join these calls.
Yeah, welcome. We are just going over a deep briefing on the EMEA summit that we had just now, and Babak presented our Workstream's initiative works there.
Excellent. Yeah, I'm able to join because the utilities of California are paying for me to participate in activities like this related to the energy codes. So in this case, ASHRAE and IECC have the opportunity to influence some design choices for data centers as very energy intensive buildings. So that's I'm coming from that perspective. Thank you.
Wonderful. It's good to have a different area of expertise here to help us. Yeah, thank you for that. Yeah, and I used to be in Intel and retired. Now I'm helping OCP some of the initiatives here, and maybe Babak, you want to?
Yeah, I'm a professor of computer science at EPFL. EPFL is a polytechnic in Lausanne in Switzerland. And I'm also the founding president of the Swiss Data Center Efficiency Association. So I have a couple of hats, and I'm in this work stream with my SDEA hat. And at SDEA, we have an online platform to calculate DC energy flow efficiency, IT stack efficiency, and we also have a calculator for sources of electricity and their emissions. And we also have a label. So we're a nonprofit, and we have a label. We certify data centers. And I should probably change my background. There we go.
Yeah. Good. Thank you, Babak. And maybe probably like not part of that question, like based on our sustainability things, is there any other things people are looking, or is the performance per energy that people are thinking it's a good thing that we should be continue to work on it? What is your take, Babak? Babak,
Yeah. Are you asking me or Babak? Sorry.
Yeah. Based on the conversation, maybe offline conversation you might have had there.
with are we talking about my talk at OCP?
Right. Talk plus maybe additional side feedback you might have got regarding.
So the feedback was that I don't know if James is familiar with what we presented. We're looking at how to come up with proper metrics for IT efficiency in this work stream. So the first milestone was last year. Sammy presented that on infrastructure utilization effectiveness, IUE, and that breaks down the rack into what part goes into the servers, what part goes into power distribution, what part goes into thermals, and what part of it is just idle power. This year we presented with our work on, we need to break down now the part that's computation into metrics that we can properly measure. Maybe server vendors can provide also help in the server so we can instrument these things and measure these metrics. We're looking at metrics at the CPU level, but what you have the software running, translated machine instructions have they taken a couple of 1 to 2 orders of magnitude in actual raw efficiency out, because there's a lot of bookkeeping when you do arithmetic with machine instructions. Then there is memory, then there is there's arithmetic operations based on operand data type. These days, if you look at AI, they're trying to quantize and compress AI to fewer bits. Historically, we did standard data representations because these things didn't matter. Then we're looking at memory, we're looking at storage, we're looking at network, and we're looking at what are proper ways of characterizing this. So I guess he has a link to the.
That is cool. It sounds very challenging. So
yeah.
And so when you guys use the word efficiency, I take a minute to review the words that we used in the lighting space when we're converting power to light, or energy to light. And we try hard not to use the word efficiency because you're changing the units of measure between watts and lumens. And so we very, very often use efficacy. And it's curious that, here I am coming in cold to this call and wondering again, here you are with the word efficiency, which we understand that it's just, it's nearly the same, but I wonder if it'd be more attention getting if you used other types of language, maybe with the word productivity in your term, like energy productivity, as an example, to help people feel like you're getting more value-added IT work for the amount of power you use.
Well, so let me take this question, Sammy. So first of all, in various fields of technology, in computer science, various domains, same terms mean completely different things. I collaborate with folks who do, I'm a computer architect, I design chips, I collaborate with folks who do networking. When we write papers, we're sort of swimming in this pool of words that don't actually mean the same thing. So we have to find our home. If the paper is going to a hardware conference, we use terminology that is used in the hardware world. If the paper goes to networking, we use their terminology, but we also mutually understand what these things mean. With respect to this particular field in data centers, PUE has been around for a few decades now. There are rumors that they originated from various parts of the world. There is one rumor that said it actually came from Switzerland, and there's a colleague of mine who came up with the first evidence of this published. It was power usage effectiveness And over the years, I think we have vulgarized that, we've changed that word to power user efficiency. I don't know what Sammy does. I still use effectiveness, I think, in the slides. But we're now using effectiveness and efficiency in this particular domain interchangeably. As
Okay.
long as we're staying with electricity, I think we're okay with just one term. When we go between thermodynamics and electricity, then we have to worry about the
How
proper.
about electricity and IT work?
So electricity and IT, basically, electricity directly translates into activity in hardware. And so there's no other form of energy involved in delivering that output.
No, it's
right?
it's a form of valuable work that's occurring that
Right.
is not electrical in nature.
Right,
It's not
exactly.
energy.
So in
So-
computing, historically, in computing, the term efficiency in the 70s was used to explain when you do things concurrently. We use multiple computing elements to perform one task. What is the parallel efficiency?
Sure.
So
Well, that's like that's a time efficiency thing.
Yeah.
In that case,
So,
I understand that.
But we don't have in computing per se. I don't know in engineering, but in computing we don't have productivity properly defined. It's not a term that's used. Efficacy is not used in computing. So yeah, I think this is where we are right now. But that's a good question.
Yeah, thank you. So for instance, when you have a busy computer and it's got choices were made inside the computer to do value-added work, and then maybe choices about less value-added activities like overhead or whatever, but it's still IT busyness. It's just not IT value. So I can imagine certain architectures make choices about how to limit the non-productive IT work that doesn't provide value to the customer. It might be required for the architecture to operate correctly, but it might be considered overhead in the IT space. So this is more of a philosophical thing we should maybe having over beer and wine, but it's just a matter of thinking this through with my new ears. I appreciate that. Thank you.
It might be a good opportunity to also see where terminology is needed and revisit it and create a proper terminology. I mean, that's also part of what we do. So
Yeah, I think that's a good question. I believe the one of the reason we were kind of tying around, like, can we use still effectiveness rather than efficiency? The one of the reason was the sum of the formula we are putting is a divide by 0 goes to infinity, right? If you look at PUEs, the minimum values, I mean, if it is fully effective, it's 1 to infinity, right? So we were trying to avoid the infinity problem when you're putting in the formula. That's why we were kind of looking for a term, and we said, like, hey, maybe efficiency is good enough. But if some other terms are getting used in the industry that conveys a better term, we should revisit and see how you want to use it.
Oh, that's cool.
Yeah.
If, for instance, I'm drawing a parallel to other industries. So in this case, an industrial factory, they use terms like process load over there, where they're converting energy to a industrial output that's valuable. And they use the word process load over there. And so we're also trying to use the word process load productivity or energy productivity of a process load. Like, so many watt hours in is so many widgets out, and that ratio becomes a productivity value. So if you guys could create what you could all agree on is valuable IT work per unit energy, then that's along the same lines.
Okay. Let us when we define the next one, let us have that pointed discussion and see, like, whether we want to use efficiency or productivity, or just revisit maybe some other terms available. That's about it. So going back on to Babak, any other like discussion related to the performance per energy that going for that we are looking into working on it, or anybody
No,
else looking something similar?
There was no other topic. There was just on the slide about technology and what is the minimum energy that can be consumed. I think there was a conversation about adiabatic, but I basically said yes, but that's going to be a niche technology if we get it done. There are other niche technologies, for example, quantum, neuromorphic, and that's it. And then there was this conversation with the startup that is using AI to configure servers for higher efficiency. So they monitor the servers and then they use AI to reconfigure the server for higher efficiency. Yeah. So we can invite them to the work stream.
Okay.
That's cool. So that would acknowledge that a server that's not fully busy could be, I guess the overhead of the server just running feels expensive when it's not very busy, right? So you try to keep the server busy. So this AI would kind of shift the loads to try to keep servers busy.
I think the AI is looking at the current knobs that are available in the servers, at the hardware level, at the firmware level, at the OS, and then looking at how do we properly set those knobs so that we get the same output with less electricity. So one of the things, for example, they are looking at is for a particular workload stack, the AI monitors their clock rate for the CPU and then figures out what is a proper clock rate to operate the CPU. If the CPU is spending a lot of time in memory, that will reduce the activity in the CPU and reduce the energy consumption.
Yeah, I think if you look at the slide, I mean the last link that I pasted, and if you look at slide 5, we do baking into the idle power as part of our IUE. Infrastructure utilization efficiency. We want to kind of incentivize some people really like doing this kind of work, right? Unless you measure the idle power, because that is power, it's going to be consumed regardless of workload running or not. And if people can go and figure out, hey, now I see this system is not effectively utilized. Maybe 1 or 2 jobs running, but not really. It's consuming a lot of power in the system. If you migrate the workload, you can set up that system, or you can put in low power mode, so that it's you're conserving energy, right?
Yeah, cool. And the whole idea of a hot standby machine, where like how much overhead power do you spend just keeping it ready for work, and all that stuff.
It's depending on the processor architecture, platform architecture. You can go anywhere from, I don't know, a few watts or to even milliwatts, depending on a laptop and other things, right? And how much response you need quickly when you're trying to bring the OS up, right? There are multiple sleep modes you can put it, and also you can bring it back. But there is a long latency if you're trying to put the lowest power sleep mode, right? But it's generally like, if you look at a data center side, the works are not coming very quickly, right? It's, your schedule generally, like when you're going to get a higher load and you have to spin up more computer, you can get that systems ready, right? You can think of hot, I don't know, cold and warm, and you can have multiple categories there, right?
So if you have a lazy data center that doesn't care about that, they would just keep everything running and not think about it. And part of this conversation involves thinking about it and modulating equipment readiness to save energy.
Yeah, that's why we want to first create a metrics so people can measure and report it. if you start reporting it, right, that is another thing we want to produce a performance, right? Today, there's no normalized performance. If we can able to marry the performance, then you can say like, yes, how much it's getting utilized, how much your power you're consuming. Is it, then you can compare with somebody doing real optimization and say like, say I'm running same workload, but I'm consuming low power, right?
Yeah.
But I think the first thing is get the metrics out.
Yeah.
What type of metrics you want to go for?
The way the market is positioned, James, is that the hyperscalers already count the electricity into their budget, right? And it's not a big part of their budget right now, but they load the servers exactly at the right sweet spot so that they deliver their objectives in terms of the service level sort of agreements, but then they pretty much consolidate the servers. The sort of the mom and pop data centers around the world, the customers of co-locators, Europe here is a co-location market. That's where the bigger problem is with the IT stack. Now, this particular metrics that we're talking about here can help both. It can help operators anywhere in the world have a better idea as to how well they're loading their IT stack.
So, Babak, any other additional observations from any other teams that any additional metrics we should be kind of looking there based on at least
No, I mean, I think you're probably aware that most of the sustainability track is focusing on scope 3.
right.
There's a lot of most of the talks are about scope 3. I'm the only one who gave a sort of operational
Okay.
emissions, right? And I had this saying at the beginning that it's 75% operational emissions.
Okay.
But everybody's talking about scope 3, so.
Right. Okay. Yeah, I think that's a kind of interesting things to observe. And also, is there any kind of people interesting on the sustainability metrics? I mean, not the profile. That any talk, maybe some other conversations from the other work groups.
No, there wasn't. I think we had a couple of slides on the profile, and we decided not to present them because I saw that you had them at the end of or maybe Jeff and us, we decided.
We had one slide because we moved a couple of slides to the backup.
Right.
Right.
Yeah, I think it would be good to I think I didn't present Jeff's latest work on that, but I think he talked about it last year in San Jose.
Right. Yeah. Okay. Yeah, I think we just need to finally release the final thing. We are trying to see any inputs or any people have any issues there. Right? Yeah. So thank you, Babak, for that. I didn't get any update from Sadas whether he's able to join or not. The one thing we were kind of looking, even we presented like performance per energy. What is the infrastructure we want to put together, right? At least for me, to get the transistor technologies and the process technologies, however we want to embed and how we want to represent, that is one area we really need to think through, because even if you look at one processor, they might have multiple different technologies going through, right?
Yeah, they have. That's both within the chiplet and across chiplets. Yeah.
Good. Right. So we need to, if you want to go after that, right, we need to really figure out how do you want to generalize the representation. Maybe a container or something which can have multiple different parts in it, right? Or maybe a system, and under the system you could have a processor, or you could have a memory, storage, all kind of things, right? We need to see like how do you want to get started, maybe, or maybe do we want to even get some numbers without even before going and representing it, right? Do you want to put together a system level information there or not, right?
I don't know if Sadas has access to device level information. So if he has, then he can sort of dive into that. I can probably help more with the ISA level sort of metrics, because that's the level I have access to, and I also have access to workloads
Okay.
in the lab. So yeah, maybe we can ask. I don't know. What do you think? I think it would be good for Sadas to maybe look into the device information.
Yeah, I think we should ask him what type of information he has, and what is. I mean, at the end of the day, are we going to get an attachment? People are they going to be willing to publish that, right? If we are not able to get, is there any proxy for it, right? That we need to think through.
Yeah, I also think that we probably, as a group, need to have a minimum milestone that we
Right.
should advertise, right? We may not be able to dive deep in all pillars in detail, given the availability of resources and information, but we should have a goal as to what is the minimum that we want to achieve, so that if it gets too big, we don't just leave it halfway and abandon it, right?
Right.
We get, I mean, I think last year's milestone was a very good milestone, right? I think we need a
Right.
milestone for the next step.
Right. Yeah, I think you're right. I think we do need to put a performance per energy milestone, because I think when you look at our I believe the slide number just for James, right? It's a first link. What we are
Yeah, these are
talking
great.
about.
Thank you. Yeah, I've got
Slide number
already
14.
downloaded. Okay.
Slide number 14 is the one we are trying to say, like, we need to start looking at the infrastructure portion of it. But I'm kind of looking is our next step is to say, like, hey, what is the I think if you look at that slide, we are talking about transistor technology, instruction storage, and data movement workload profiles. We need to figure out what is the infrastructure we want to put together in order to represent that. Maybe I think if we can get Sadas in, and maybe if we can get some more additional people, we should start discussing on what is that infrastructure we want to expand on it, right?
How easy is it to get people to be a little open with their data? Doesn't some of this point to quite proprietary choices they're making in their architectures?
That is a challenge. That's why I'm saying, what is the proxy for it, right? We need to think about it. Yes, transistor technology is going to be proprietary, but it may translate into how much power going to be consumed. I don't know, depending on same workload running on a different process technology or different systems, right? We need to figure out what are the proxies that we can say, like, if you put a proxy or some normalized way, people they put some numbers there, right?
Does the industry organize standard benchmark workloads that everyone agrees on that you run and outcome some numbers? Or
that problem is benchmark gives you offline system capability. What we are really looking for is when the workloads are running, real life workloads, how do we measure the performance? It's the max characteristics is not helpful in most cases. And even that performance, we are looking for a normalized number, because if you take a system, a normal compute system, you could have VM is doing some office work, it maybe another VM maybe doing some AI work or something like that, right? It's all mixed, right? How do we create a real life normalized number people can agree on to say like this is a performance produced by this compute system or compute storage or whatever the things you mix them together, right? And that's been a challenge. I believe that's where trying to see like what type of infrastructure we want to create so that we can measure that all the compute goes in, all the energy is going on a different instructions that's getting used and different data movements going on in the system. And can we get some kind of normalization so that we can say like so much compute is performed without even looking at what workload you're running, right?
Right. Understood.
And
Man, I'm glad you guys are working on that. It sounds very helpful.
and I think that's one of the things we are seeing a lot of challenge even today to get how many integer or floating point instructions being used. You have to do some additional profile to really get the numbers. There's no numbers getting represented outside the system. We can go and readily get the number and say like, hey, so many operations happen in this processor.
Okay. It's almost like you need the workload to have internal telemetry that's lightweight that can then report this out, right?
Right. I think the lightweight may be an initial target, but eventually you want to tell like, hey, can you even give that number from the hardware, right? Every hardware can look at because they have the numbers. They're probably not creating counters for it because it's not nobody is asking for it, right? And we need to figure out what exactly what need to look like. There's no proposed solution right now available.
Yeah, there's also a difference between having this infrastructure so that the hardware can be rated, compared, versus having this infrastructure monitoring actual workloads in a deployed environment, which both are important.
Right. Thank you.
Yeah. Non-tampered way of measuring it, right? Because people can measure and report, and they might say like, "Hey, it's not a real thing," right? You want to define an ideal architecture, maybe work backwards and say like, what can be done today, right?
Well, can you compromise with some you all agree are kind of terrible, but better than nothing sort of metrics? What's the industry using it as better than nothing for IT value quantification, I guess?
Yeah, if you look at a lot of cloud renting, they do have a meter, right? They have a meter for a lot of things, right? Without that metering, they're not able to charge you. Even if you look at a number of tokens used, or if you look at VMs, they have a how much. There's multiple areas, right? You can buy a VM, you can do whatever you want, but they even measure how much memory you are using. They can throttle it, all kind of things sitting there, right? There that may be a proxy, but you can say like, yeah, we need to get all the numbers, then you can put them together and collectively and say like, here is a performance, right? But again, people should be willing to get the number and publish it, right? How are you going to get it published? Maybe I think initially like you have to go with internal tools that is available. Then maybe we need to look at some way to publish it in generic way, right?
Thank you for the
And again, we are
extra
looking for
words.
proposal. If you have some alternatives, you guys looking into that, we would like to hear from.
Excellent. Well, it's a pleasure meeting you all. I'm going to dash, and thank you for your patient slowing down for me. And I look forward to finding ways to map this to ASHRAE's work, and maybe California. Sometimes California has a special budget for extra experimenting like this, so feel free to imagine you could find some budget. And what would you do with it? I'm happy to help you find a way to spend that, you know?
Oh, that's wonderful.
Yeah,
Yeah,
we would love to hear from you too, James, about what ASHRAE's interests are in this, and how where the boundaries are in terms of the kinds of domains that you're interested in, because this is not, we're poking into the IT hardware.
Yep.
It would be really good to see a sort of bigger picture of where you guys fit in.
Yeah, thank you. As we know, there's a lot of cooling, a lot of care on the cooling side, right? Maybe a moderate amount of care on the power distribution side. Maybe there can be some improvements there. I think this is really a blank sheet on the IT work productivity thing. So I'm looking forward to what I can do is, now that I know you guys exist, right? Now I have two names I didn't have a minute ago. I'm going to go back to California's list of work that they're busy doing. And I'll send you guys a note if I find something that we could translate to what you guys are up to.
Wonderful, wonderful.
Excellent. It's nice to meet you guys. Have a nice weekend.
Nice to meet you.
All right.
Thank you,
Bye.
James. Yeah.
See
Bye.
ya.
Okay.
So Babak, I'm trying to see like, is there anything else we want to discuss today? Or
No, I'm good. I have another meeting
okay.
in a couple of minutes.
Maybe I think the next meeting let's ping others and NEC2 to make sure that we could start discussing what is the next steps and maybe putting a deliverable timeline.
Yeah, that would be good.
Yeah.
I think our big next deadline is OCP in San Jose, right?
Correct. That's a deadline. I think two things I'm kind of hoping we can get it done. All the profiles getting released with the even IUE, all those things fully spelled out there. The second thing is, and that is where that performance per energy, right? It's wide open. A lot of things can be done. Maybe we should identify what is the things we can really accomplish by the global summit and what we want to target to present. And I think there should be some actionable items from the others. Is that what is that people are willing to kind of provide that, right?
Yeah, exactly. We get, two things. Basically, one, midterm milestone, a minimal sort of milestone, right? And then the second thing is the pillars. Who can dive into what and who can provide what?
Right.
Sounds
And
good.
the other thing we were kind of discussing a while back, the storage and the network, all those things kind of disappeared. Now we have to think, do we want to revisit or how we want to look at it, right? That probably a data moment problem. I think that's generalized in a way, right?
I mean, what I can do with all of these microarchitectural metrics at the software hardware interface level, whether it's arithmetic within the CPU, whether it's network, whether it's storage, I can do a characterization within a lab environment and then present that, right? I have resources to do that now.
Okay.
How we can start with that and then going from that and okay, do we have deployed information from someone who can do a comparison, or at least we can talk about what I'm presenting and say, does this even make any sense?
Yeah, I think that's a good point. I believe if there is a lab environment, people can really measure and at least get the numbers, and we can start looking at it, right?
Yeah. I have to talk to my colleagues because we have an experimental data center here at EPFL.
Okay.
I created this center called EchoCloud. Now they own a part of a data center, which is an academic experimental data center. I can ask them what are the things that we can measure, what are the things we cannot measure.
Okay, that's a good to kind of get that baseline. We need to kind of look at multiple different avenues. How do we make the progress here, right?
Sounds good. Yeah.
Right. Okay, let's probably next week. Just let me ping Sadas and the NEC2, and if they can join, then we can let's have some concrete conversation and finalize that.
Have a great weekend.
Okay. Thank you, Babak. Thank you for presenting. We'll see you next week.
Absolutely.
Bye.